Let's take a look at how we can use some calculus, tangent line approximation, also known as linearization, to do some basic arithmetic. In this first one, we're asked to find 1.97 cubed. Now you could go ahead and multiply out 1.97 times 1.97 times 1.97 without a calculator. You could do that. But let's talk about how we can apply some calculus to make it a little bit easier to get a pretty good approximation of that decimal value. If you think about our linear approximation model, recall that it goes L of x is equal to f of a plus f prime of a times the quantity x minus a. Now, we need to determine what the function is we want to use for the basis of this linearization, as well as the a value that we're going to target. Well, since we have something that we're cubing, it makes sense to perhaps use a cubic equation. So we're going to use f of x equals x cubed, because we're really wanting to take a number and cube it. And the a value, we want that to be something pretty close to 1.97. Again, think that delta neighborhood. So maybe we can use 2, because 1.97 is pretty close to 2. We need to substitute in to our linearization equation. So we know a, we can therefore do x minus a, that's easy. F of a, let's do that. So we need f of 2. So we simply want to substitute into x cubed. That gives us 8. So now we have f of 2 that we need. We need to do our derivative. So let's do that. Derivative of x cubed is simply going to be 3x squared. We need to evaluate that at 2. That gives us 12. Now we should have all the values we need to substitute into our linearization formula. So we would have L of x is equal to f of a, so remember that was 8, plus f prime of a, that's really our slope, that's 12, and we have that times the quantity x minus 2. So we can simplify that a little bit, and we obtain the linearization 12x minus 16 in the end. So if we want to approximate now the value of 1.97 cubed, remember the whole idea is that we can substitute into this linearization equation we obtained to get an approximate value of the real true function value, 1.97 cubed. Remember, it is only approximately equal to, so you definitely need your approximately equal to symbol. We're going to do 12 times 1.97. Notice how we're substituting in the actual value we want to cube in place of this x. And then we need to subtract away 16. You do that, you can grab your calculator to do that, you get 7.64. Now you could go ahead on your calculator, since you have it there, do 1.97 cubed. You should notice you get something pretty close to 7.64. Let's take a look at another one. Here we're asked to find the square root of 24. Well, we can estimate it pretty good. We know it's going to be in between 4 and 5 because we know 4 squared is 16, 5 squared is 25. So square root of 24 should be somewhere in there. Once again, we have our linearization formula. Now we need to determine the function that's going to serve as the basis for this. Since it's a square root function, we might as well do square root of x. Now we need an a value, and we want it to be something. Remember, we would substitute this a into the square root of x because we are going to need f of a. So we want it to be something that's a nice square root that we can easily do, but not too far away from 24. So let's make it 25. That's kind of like having a delta value of 1 unit, if you think of it that way. We are going to need our derivative, so let's go ahead and do that. We're taking the derivative of square root of x. That, of course, is going to be 1/2 x to the negative 1/2. We could rewrite that, if you care to, as 1/2 square root of x. And we need to evaluate that at 25. If you substitute 25 in place of your x, of course you get 1/10. Now we have everything that we need to substitute into our linearization formula. F of a is going to be our f of 25 value, so that's simply 5. Square root of 25 is 5, plus f prime of 25, that's going to become our slope. That's 1/10 times the quantity x minus 25. If you go ahead and rearrange this, distribute the 1/10 and simplify a little bit, you obtain 1/10 x plus 2.5. And that becomes our linearization. We want to use this to approximate square root of 24. Again, the key word, approximate. So we have 1/10 into the x, we're going to substitute 24 itself, plus 2.5. We end up with 4.9 as our answer. Remember, we had said it would be in between 4 and 5. Makes sense, it's closer to 5 because we're doing square root of 24, which isn't going to be far from square root of 25. Definitely makes sense. It's close to 5. You can go ahead on your calculator and do square root of 24, and you will find that it's pretty close to 4.9.